Hello, everybody. I'm so happy to be here. The schedule says I'm going to give a talk called Build Reasonable Software, but as you can see, I had the brilliant idea about 24 hours ago to switch it up a little bit, and I figured I have a long flight to London, and I have plenty of time to make these slides, and then the flight got pushed back, and then the plane had no Wi-Fi. And so we are all going to find out what order the slides are in together after we squeeze through something that is very much in the program and something that I'm very excited to talk about. But when we get to the back half of the talk, I want to talk about something that I'm exploring that we have not talked about, my team and I, publicly, that I'm really curious for your feedback and your thoughts on, so please don't be shy as we get to the end. But in order to dive in, this is the Pydata conference, and like many of you, I'm sure, I discovered Python because I was trying to learn R. Once upon a time. You see, I started my career as a statistician. For a couple statisticians out there, I felt a need to explain this. I was going to say a statistician is what we're called like a pre-machine learning data scientist, and it comes from the Greek word for boring, as far as I can tell. But what brought me to Python, therefore, was not Python itself. It was numerical Python, right? It was NumPy. And I'm sure for a lot of you who have been in this ecosystem and community for a while, it was something similar, right? Maybe it wasn't NumPy, maybe it was Pandas, or scikit-learn, matplotlib, PyTorch, PySpark, DuckDB, maybe even something I'm involved with, like Prefect. Whatever it is, and there's a million other logos to be sure of phenomenal pieces of software, this is what obviously we have come to call the Pydata stack. And Pydata has become, in my opinion, the gold standard for software ecosystems. And I find it fascinating to study because despite the fact that there is a community here and that there are organizers of this conference, there is no official membership to Pydata. It's not like someone is handing out, you're allowed in Pydata and you're not as a software project. There's something very special happening here. And I don't think it's enough to just say that these are great pieces of software, because there are many languages and many ecosystems that also have great pieces of software, and especially numerical and scientific and data, now AI software. Instead, what I think it is that all of these pieces of software, they feel aligned in a way that is culturally correct. There's a cultural affinity between all of the tools in the Pydata stack. And this has become so important, it creates a network effect. When you use one tool in the Pydata stack, you tend to know how to use another tool. And this actually has been so influential and so broad that we have a word for this, right? We call this being Pythonic. And this is such an important concept to me, to my team, to all of you, I'm sure. But the funny thing is I don't think anybody really knows what it means, right? I use this phrase all the time. But if you actually sat me down and were like, well, why is it Pythonic? Or why is this not Pythonic? I would struggle. And if you go online, you search for this, you see things like Pythonic means it uses the idioms of Python. Or Pythonic means it uses the conventions of Python. And it's presumably true that in order to be Pythonic, you have to use Python. That's a good entry fee to pay, but I don't think it does enough because there's plenty of Python software that is not, for some reason, Pythonic. And so we're stuck with this question of what does it mean for something to be Pythonic? And while I don't know that I can offer you a definitive definition, I can offer you some insight and some intuition into what I think is super effective here. And it really comes down to three things. Pythonic software, in addition to being written in Python, is atomic, it is composable, and it is simple. Atomic means that abstractions tend to do one thing, one clear thing. Composable means that you can take those little Lego bricks and you can build whatever you want out of them. They work together. That's critically important. And simple is simple. We try to build software that is as simple as possible. And when you get these three components together under this banner of Pythonic, I think the most important thing that results is you get software that is easy to reason about. And I think this is the highest calling for software that we write. I'm a tool maker. I like to build frameworks. My frameworks are worthless if I can't get anyone to use them. And the only way I'm going to get people to use them is if it actually solves a problem for them in a way that they understand. If I solve a problem in a magic way, I'll get one user one time. That doesn't actually help anybody in this situation, especially now that AI can vibe code anything you want off the top, and it's a black box, and it's not necessarily easy to reason about. So this is the highest calling of software, and I mean, if you go and look at what Guido said on this, he has this famous quote, "Code is read much more often than it is written." And so when we are producing anything, code or any technical abstraction, I think that the most important thing to do is to remember that you are writing it to be read or to be interpreted, or if you work on a team, to be modified by someone other than yourself in the future. And that someone increasingly is a machine, but they still need to understand and work with the code. And so there is a debate right now, which I'm going to caricature, as whether or not writing code that's easy to reason about matters more in the age of AI or matters less in the age of AI. I think strongly it matters more. I think that we do not see a tendency where machines, AIs, LLMs, are gravitating towards more and more low-level languages. Instead, we're seeing a push towards token efficiency and speed and reducing latency, and that's going to have us reaching for high-level languages. And then, of course, how many people here have asked an LLM to change something and gotten back a 10,000 line diff? It's ridiculous. You want the code to be easy to work with, that is to say simple. You want it to be composable so that we can snap the blocks together. And you want it to be atomic so that one change equals one change in the code base. This is like critically important, especially in the age of LLMs, I would argue. And so this is the calling not just to build software that is easy to reason about, but the way I would prefer to say it, build software that is reasonable. That is what we are trying to do. That is what we want our agents to do. And I think if you can start, if you are using an agent to write code, and I'm assuming most of us are, anyone here proudly not using AI to write code? One. You may not enjoy the rest of this talk, but I have enormous respect for you nonetheless. I love that, actually. If you are asking an AI to write code for you, please don't just tell it what you want done. Please ask it to interrogate the abstractions in that code, to contribute its own. And if you keep these Pythonic, or if you're not using Python, keep those same 3 principles in mind, I think you will get much, much better software out of it. And I think that the history of Python itself is about taking something that people want to do and making it feel a certain way. And I think that's why the Pydata stack won. It took a lot of things that people wanted to do in C, in other languages, and it brought it into a familiar and easy to use and accessible place. As was mentioned, a piece of software that I wrote a year and a half ago has now become by far the most popular piece of software I ever wrote, which is very, very exciting to see. But if we boil it down, all FastMCP did when I introduced it was it took something very complicated, the model context protocol, and it made it feel like Python. We took a function like this, get a weather forecast, we put a decorator on top like this, and now the entirety of the MCP spec is at your disposal. That's why FastMCP won. That's it. In fact, this is literally all FastMCP was when Anthropic took it and made it the official SDK for MCP. Since then, we've had a lot of opportunities to think about what are the abstractions in play. What are people trying to do with model context protocol servers? What are they trying to do with agents? How do we work with them? And so FastMCP has gone from essentially this decorator into a version 2 that added every piece of functionality under the sun. 2025 was a very weird year to be working in the MCP space. People either loved you or hated you. It's somewhat still true, I guess. But we spent a lot of 2025 just desperately trying to ship the features that people wanted. I want to do this. This is what's hot in MCP. We're trying this. Auth sucks. How do we do this? And we would just ship. We would ship. We would ship. And what happened is every single feature ended up with its own code path. Every single feature was 3,000 new lines of code because I couldn't reuse any of the abstractions because there were no abstractions. I was very willfully violating every principle I just shared with you about what it is to build reasonable software. And I got to a place where simple enhancements, little issues people would open in the GitHub repo that should have been 5 minutes, ended up being these massive PRs, and just something was wrong. And so at the end of last year, I got fed up with this, and I was like, this is just not a good framework, frankly. At this point, it's just a bunch of features bolted together. And I was like, let's go back and let's redesign the whole thing. And so the result was FastMCP 3, which in my mind is a well-designed, it's the first time it is even a designed framework at all, to be honest with you. But it does the job it's supposed to do, which is makes it easy to work with a very complex protocol through a bunch of abstractions that are atomic and composable, and in my opinion at least, simple. And I actually got a really interesting natural experiment that was run here that I can point to. How many folks are familiar with code mode? Or maybe I should ask, is anyone here unfamiliar with code mode? We have a few. Code mode is a really interesting idea. So when you use an MCP server, you have this problem which is that discovery and iteration, which are the two principles that we as humans leverage enormously. They're very cheap for us as humans. We discover an API once, and then we write a lot of code to iterate quickly over it and call the endpoints. Very, very, very hard for agents to do this. Literally very expensive in time and tokens to call a lot of endpoints. And so one of the biggest challenges with large MCP servers is if you can get over the sort of context lobotomization that happens when you connect to them, you have to call like 10 tools to get anything done. And it takes a lot of tokens, takes a lot of time. And so Cloudflare originally came up with this concept, which has been picked up elsewhere, called code mode. And the idea is that instead of having the LLM call those tools in a sequence, which is expensive and slow, you write a small script which itself calls the tools. And then you submit that script for execution in a sandbox, and it calls the tools really quickly, solves the iteration problem, solves the discovery problem because it happens once. And it turns out to be extremely, extremely effective. For complex server operations, you can get north of a 90% reduction in tokens and time if you use this appropriately. And so, of course, we were really excited. This is something we really wanted to add to FastMCP. And so one of my colleagues took it upon himself to add it. And it happened that at that time, we were in the middle of the transition from FastMCP 2 to FastMCP 3. And so his first PR was against the FastMCP 2 code base. It was 2,500 lines of code. And I'm looking, I'm like, it can't be right. It just cannot be right that it's this much. When he wrote it against v3, we got that down to 400. Same exact logic, same exact everything, as a matter of fact. Same exact user-facing interfaces, but because the framework itself had been changed to permit the reuse of its own abstractions and compose them in a more interesting way, he was able to get this massive savings, which made it a lot easier to accept the PR in a way that is heavily used. I don't know if, how many of you attended Samuel's keynote yesterday and saw the Monty. OK, so our code mode is based entirely on Monty, which is one of the first, I think, widespread uses of Monty, as a matter of fact, because the second it was announced, we were like, hell yes, let's use this. The 400 are basically just orchestrating Monty at this point. The other 2,000, reinventing halves of FastMCP that weren't well designed in the first place. And so this is what it is if you build reasonable software, and I'm very fortunate to be able to use sort of a garbage version of my own software contrasted with what I think is now a very good version of my own software, so I don't have to call any of you out. I made the mistake, I fixed the mistake, and this is the type of benefit we see. And so this is super exciting. And as we think about MCP as a way for us to work with AI agents, and in particular, as we think about MCP servers as things we want to reason about through frameworks like FastMCP, it becomes interesting to think about the fact that the consumer of this server is itself doing a lot of reasoning. And so when we talk about best practices in MCP, it sounds kind of weird. If I went back 10 years and said, well, best practices in MCP are make your functions easy to read, and make sure your doc strings are clear, and don't use abbreviations for variables, you'd think I was crazy. But the consumer of this is an agent. Clarity matters. The ability for it to reason about the API itself matters. And so one of the things that's gotten me super excited in the MCP space is the introduction of MCP apps. Again, I'm just curious how many folks have seen an MCP app in the wild. A few. So this is very new. This is the first extension of the MCP spec. I think it was adopted in January or February of this year. So this is very, very, very brand new. An MC app is a cool idea. It says, look, we have a good contract now between a backend and an agent through MCP. But it is exclusively through the backend and an agent. What if we want to get a human involved? What if we want to ship an actual UI out to a person? How would we do that? And so MCP apps is a protocol extension that lets us ship a full UI over the MCP protocol. And the idea is skip the agent. As a matter of fact, as we'll see, we can take advantage of that by skipping the context window and go straight to the user and show them something interesting. And so I think this is incredibly cool, and I desperately wanted to put this functionality into FastMCP. But I did not want to go down the FastMCP 2 rabbit hole, and in particular, I had a more pronounced version of that problem with MCP apps because it's a UI. The best-in-class tooling for a UI is always going to be in the JavaScript ecosystem. I did not want to copy that into Python. That would be a bad use of Python. It would absolutely not be Pythonic. It would not feel good. And so I really struggled with this. How am I going to bring these idioms and these use cases into Python? And so I thought about it a little bit, and I realized that there are a couple of advantages here that I could take advantage of. Well, that's redundant, but I'm jet lagged, so we're going to say some odd things. There are a few things here that I could take advantage of. The number one is, what is my user doing? What are they actually doing with my framework? It's not especially general. There's a very specific thing they're doing, and that is they tend to be inside an enterprise sharing information with their colleagues. That is the #1 use case of MCP that we see within the Python development ecosystem. May not be true in the broader MCP world, but Python developers of MCP sharing data and information inside their organization. And that means when we think about the MCP apps that they need, they are fundamentally things like tables, they are fundamentally things like forms, and they are fundamentally things like charts. They are not trying to ship branded, custom, consumer-grade UIs. They are trying to communicate information to humans. And so with that constraint in mind, I wondered if we could actually build a more reasonable piece of software to deliver against that objective. And this is the fundamental question, of course. Can I make that use case feel Pythonic? As a matter of fact, I think we can. And so we introduced a new library a few months ago, which I'd love your thoughts on, called Prefab. And the idea here is not, again, to build a front end from scratch. The idea instead is, can we compose prefabricated existing components, high quality components, into a UI that is usable by humans for this use case? And so to illustrate that, here's a card. You might see this as the hello world in any front-end framework. There is literally nothing special about this card. It works exactly like you think it would, with one exception, that the code behind it is 100% in Python, and it is 100% done with composition. So if FastMCP's innovation was to throw a decorator on a function and call it an MCP server, Prefab's innovation is to throw a context manager on a function and call it a UI. And that's it. That's kind of all you have to know. This may be a little too small for those of you in the room to see, but essentially we've got, oh, I can't leave the mic. We've got a card, some card content, we've got a column, we've got a card footer, we've got a row. We define them in context managers, we put things in them, and the framework takes care of fully compiling that. It's a JSON protocol over the wire, and it goes out as a native MCP app to users. Context managers to the rescue. And to me, this goes back, and this is exactly Pythonic, even though the use case is terrifying, and you might even say unreasonable to build a front end in Python. But context managers, we're using an idiom of Python, yes. We're doing it in a way that's composable. I think it's simple. You tell me after you get your hands on it, and certainly atomic. And the most important thing, the insight, the constraint that made this possible is that we are composing UIs in Prefab. We are not building UIs in Prefab. And this made me comfortable bringing this to bear. So here's what this looks like in practice. Here's another MCP tool. This one is a team directory. So we've got a function. We throw a decorator on it. Now that's going out to an agent over the MCP server. Here's an extension. I import a couple of components from Prefab. I return those instead of my raw data, and that's enough. FastMCP now knows your intent. It knows what to do. And if you're in a client, this is in Goose, and you say, show me the team directory, you get a beautiful table. It's filterable, it's paginated, it's searchable, it's sortable. It's all the things you want it to be. And most importantly, it does not go into the context window of the agent. And why does that matter? Because if you want to go and have, let's say you have 10,000 people on your team, to extend this example. In a traditional tool, that 10,000 row list is going to go into the context window so that your agent can decide what to tell you about it. With an MCP app, we bypass the context window. It comes straight to you as a user, and now you can interact with that data in a rich way. But a table might not be the only way you want to interact with it. So what if we want to put a pie chart in there? Very simple. We're going to now compose the pie chart in the data table in a grid with a context manager, and when I ask again, I get a pie chart next to my data table, and it's interactive, and it works, and it's all shadcn. And if you want to tweak the CSS, go right ahead. There's someone who has made a Windows 95 theme for this. I've seen a MySpace theme for this. It's just any shadcn theme actually should work. We're using best of class. We didn't reinvent anything here. We're using best of class tooling in the front end world, and we're just introducing a compositional, extremely Pythonic interface for defining it. And the last thing this lets you do, which I think is super cool, is a GIF that won't play. So I will send this out later. What this should be showing is a fully generative UI. Because this is a JSON protocol, we found that any agent can stream a UI over the wire, and we can render it in line. It turns out that if you stream the Python instead of the JSON, you get a token saving of almost 70%. And so we are actually now streaming Python over the wire. We are not using Monty for this, unfortunately, because Monty doesn't support context variables yet. It just introduced support for context managers, though, so I'm very hopeful. But we can stream over the wire. I apologize, it's not playing behind me, because the whole point of this is that you would see it. But it lets an agent dream up an entire UI, and it's done entirely in Python because it turns out to be way more efficient, token efficient, than sending JSON over the wire. And so that's prefab. I hope you all take a look at it. This is either the most reasonable or the most unreasonable piece of software I've ever written, but it is new, and I thought it was going to be how today's keynote went. But instead, I decided to compress all that and had a fever dream on the plane, and now I want to talk not just about reasonable software, but about reasoning software, because there's something very interesting happening right now. Back to that quote I showed earlier, we used to write software in order for it to be read. A different way of saying that is, as a framework builder, I wrote software for building software so that other people could use those abstractions to create something new. Today, we do something very different. I now write software so that software can build software. And that's really weird. It introduces a new chain of reasoning. How do we reason about the behavior of that piece of software? I don't really think about this when I think about my human colleagues. I never try to pry open their brains and wonder, like, well, what makes you tick? It's kind of not possible. But with software, I have an expectation that we can actually apply these abstractions, and it bothers me that I cannot do that fundamentally with an agent. If your experience is like mine, you ask an agent to do something, you go make a cup of coffee, you come back, it's not done correctly, you yell at it, you go make a cup of coffee, you come back, and this goes on for a long time. The slides we're about to look at were made in that process, as a matter of fact. So it's very, very near and dear to my heart. This is state of the art in agent governance. This is what a workflow looks like, potentially even a critical workflow. This is a skill for handling a customer refund request. We ask the agent to observe a few rules. We then ask it to potentially issue a refund, but God forbid it should skip the actual check and just issue the refund. What does that mean? It means that this agent is going to be given all of the tools that it needs up front, including one for issuing refunds, just in case it needs it. And we could represent that. I apologize if this is a little bit small, but we could represent that as this box, which is an agent harness. We have an agent inside of it, an agent runtime, an agent loop. And I've put some icons on the bottom, and if you can see, and I apologize it's small, if you can see, maybe I can make it bigger. Hey, HTML to the rescue. One of these icons is in red, and it's an emoji of money flying away, because this agent has been given the ability to issue a refund, and it's been given a very polite note explaining when to do that. I don't know what industry you all are in, but if your company is putting that skill into production, I would think very, very, very carefully about what you're doing. This is not acceptable. This is not governable. This is not auditable. This is not observable. We cannot allow agents to operate in this manner, and yet this really is state of the art. We haven't come up with something better yet. Now, my background, some of you will know what we've been up to at Prefect before FastMCP. We make workflow software. We think about this type of problem all the time, but we think about it for software where we fundamentally control the implementation. And what's different about agents? We don't control the implementation. That's the whole point. They exist on this spectrum that ranges from control to autonomy. And the problem is, the more autonomy that I give an agent, the less control I have, the less confidence I have. Whereas if I take full control, I am depriving myself of the magic that makes the AI do anything beyond what I can write myself. And so I believe that this tension is at the heart of what's happening in AI engineering and AI development right now, which is, of course, largely centered on the Python world, just de facto. And what this boils down to me, a different way to invert this problem is to say that it is actually an exchange of control problem. The central problem in AI engineering today is not how to get an agent to do something, it's how to know when it's done it. And so if I could know that an autonomous agent was finished doing something so that I could objectively, programmatically move on to the next thing, my life would be a lot better. I would have a way to exercise control without worrying that I'd sent it off on some infinite and potentially destructive loop armed with a refund tool. And so this is how I might choose to map that out. Now I have two nodes. One, which is a harness, and again, I apologize, it's a little small. The first harness no longer has the refund tool now. It is going to check the policy. It's going to check whether or not we want to even engage in issuing a refund. And if it decides that we will, then and only then do we spin up a harness that has the refund tool issued. That is not a complex idea. I do not think you should applaud for the fact that I said don't give dangerous weapons to agents before they need them. The problem is, I don't know of a tool that does this in a programmatic, easy to compose, and observable way. And so what my team and I have been working very hard on, and this is actually the first time I've even mentioned it out loud to anyone, so again, I'm very curious for your feedback afterwards, is how do we orchestrate agent harnesses in a way that gives them the right context and the right tools at the right time, in a way that is programmatic and observable, so that this behavior can actually be audited beyond what did the agent do when you asked it nicely and why didn't it listen to you, which is unacceptable. And I'm calling this a directed agentic graph. If you know what I do, then you know why I'm calling it this. If you don't know what I do, then this is good enough, and let's run with that. The most important thing about this new kind of DAG is that it is a graph of outcomes, not implementations. And again, forgive me for going into the weeds for 1 second, but this is super important to me. When I build a workflow in any piece of software like Prefect or any of the others that I've worked on, I am fundamentally building a graph of implementations. I want to call that function, then I want to call that function, and I want to pass the result to that function. And that is an amazing way to work with functions that are themselves atomic and composable and ideally simple. We stitch them together. When I work with agents, I either don't care or don't know, either is fine, what the implementation is going to be. In fact, I am depending on that agent to make a bunch of decisions about the utilities and the context I give it to come up with an implementation. And I actually am foregoing the ability to know that that implementation will be exactly the same time and time again. And I think it's a waste of time to pretend that we will get auditability, repeatability, observability, or any of these abilities on an agent loop itself. I'm much more interested in gaining them on the outcome of that loop. So if I can create essentially checkpoints out of the deliverable of each of those agents, all of a sudden I have a new workflow that I can evaluate, that I can falsify, that I can make hypotheses about. And so this directed agentic graph is a graph of agent outcomes. It's a graph of agent deliverables. I am willfully foregoing my ability to know how it goes about it. And so we can go back and we can look. There's a lot of orchestration stuff happening in the world that's not being called orchestration. We can look at some popular examples. This is called a Ralph loop. After Mr. Ralph Wiggum. The idea is basically you just keep launching an agent until you decide it's done enough, over and over and over and over. It is the dumbest form of orchestration. It is the most expensive form of LLM orchestration. It is a lot of superlative things, very few of them good, but it is effective, and we can represent it as a directed agentic graph in which the node feeds directly back into itself with a max iterations cap. Easy, that's Ralph. More recently, you've seen a more streamlined version of this called a goal command. This is in Codex, this is in Claude. And the idea here is a more refined version of Ralph. Here, instead of just starting the process over and over again, we're going to have first a node that comes up with an outcome. Then we're going to have a node that uses potentially a different model to evaluate that outcome. And then that agent can do one of two things. It can send it back because it doesn't like the answer, or it can approve it, and we can move on to the rest of our graph. And so we can represent, these are the two most popular forms of agent orchestration today. They are the only two that I believe are in people's hands, because I think it gets crazy complicated when you go beyond that without an observability system. So here they are represented as directed agentic graphs. We can do fan out, we can do fan in, we can do all the things that we're used to from orchestrating code as workflows, except now we're orchestrating agents as workflows. We're orchestrating harnesses as workflows. And each of these nodes has a very discrete outcome or outcomes. And depending on what the agent delivers, we know what path to take. Now, there are some phenomenal tools for building graphs like this. Pydata graph is one, line graph is one. I'm sure that there are others. This is not operating on quite the same level. So you would use Pydantic graph, for example, to determine what happens in any one of these nodes. At a more low level, you would say, after this tool is used, I want this tool to use. This is the behavior I want. What we're doing here is we're orchestrating the high-level agents themselves. Again, I do not care, very explicitly in this design, I do not care what happens in one of those boxes. The implementation is entirely in the hands of that agent and the author of that agent. And what's really cool about that to me is it means that we can do this orchestration from a server. You can bring me any client implementation of any agent that is supposed to achieve some goal, and from a server, I can now put it into a box. I can compose it with other agents that may be running in other places or written by other people, and I can get this observable structure, which I think is very useful. We can do stuff like natural language scheduling with one of these DAGs. We can have a first node that checks whether we should continue with the rest of the graph. So if I want to have an agent fire every time an email comes in with certain language, great. I'm going to schedule this whole workflow to run, say, every hour or every half hour. And the first thing it's going to do is decide if it should run. And it's going to check and see if the condition's met. And if it is, and only if it is, we're going to go on to the rest. And that to me is qualitatively and quantitatively different than writing a polite note that says, please check if the emails were written or were received, and if they were, write a reply. Because in that case, I have to give the agent the ability to write the apply. That's terrifying to me. I do not want agents to have more tools than they need at any time. This is a real governance issue. The last thing that we can do is, because these are all independent agent implementations, I can suspend this graph at any time. The graph is serializable, and its state is serializable. And so I get durable agents and durable workflows for free without actually worrying about whether or not the underlying agent runtime itself is durable, subject to the complexity of the agent. This is very interesting to me, as someone who runs a durable execution company, as a non-execution focused form of durability in the LLM space. And we can extend this to have a human in the loop as well. So I can now compose human review with agentic things in a programmatic, observable, reportable way. That's super exciting to me. And the last thing that, of course, my team is focused on is I can now have an agent decide what pipeline to run. There's no reason I can't incorporate good old prefect code or good old Python code into one of these directed agentic graphs alongside the agentic code. And again, instead of state of the art, where I'm going to ask the agent to run or write that code, but I have no way to confirm if it did. I have no way to resume from the point at which it did it, because it's all happening in a loop. I get this abstraction. And so this is that key point again. This makes agents and agent orchestration durable without a durable process, because the entire graph can be serialized, its state can be serialized, we can survive a crash. And of course, this is an introspectable control structure. I can evaluate it, I can make changes to it, I can hypothesize about it, and as long as I'm comfortable with the agent doing whatever it's going to do inside each box, I have an opportunity to express an opinion about what should happen outside the box. And this is how we modulate that spectrum from control to autonomy. Inside the box, full autonomy, subject to the constraints of the box. Outside the box, I have full control. In some, I can move anywhere along that spectrum I want. I can even have an agent compose another agent. This would be a directed agentic graph in which agent 1 decides what model agent 2 should run, programmatically, observably, and securely. And so the most important point I want to make about all this is that we're developing a system in which the control structure can be separated from the harness, so it can be serialized, it can be orchestrated from a server, while LLM authors use whatever framework they want to implement whatever behaviors they want. This gives you governance in a central location, despite pushing responsibility out to a team. And the most important thing for the purposes of our talk today, of course, is that this is atomic, it is composable, and it is simple. But we're applying it to something that today is basically, again, a polite note to an agent that is literally none of those things. At the end of the day, we end up with not just software that's easy to reason about, but software, operating software that's easy to reason about. And fundamentally, that lets us build reasoning software. So thank you all for your attention. This is all very new. We're going to be releasing a lot of stuff on this in the near future. I told my team 2 days ago, I was like, I'm going to tell the nice folks at Pydata about these new kinds of DAGs. So I would love your thoughts. I would love your feedback. I would love to know how this governance structure would work for you in your organization. And I'm so grateful that you came to my talk today. Thank you all.